Hello everyone, in this video we have this interesting problem. 9 to the power x minus 6 to the power x is equal to 4 to the power x. And we have to find the value of x. Before we begin, if you are new here, please subscribe to my channel and also don't forget to like this video. Now let's get started. Looking at the problem, it will be very easier if we divide through by 4 to the power x. So let's do that. 9 to the power x divided by 4 to the power x minus 6 to the power x divided by 4 to the power x is equal to 4 to the power x divided by the exact same thing. Now from this term over here, or this fraction over here, we can write this as 9 divided by 4 all to the power x. Likewise, considering this whole thing, we can write it as 6 divided by 4 all to the power x. Then on the right hand side, we see that this and this one will go, so we have only one here. Now, 9 could be written as 3 to the second power, then 4 could also be written as 2 to the second power, then all to the power x minus 2 goes into 6 3 times and then goes into 4 2 times, then all to the power x is equal to 1. Considering the whole of this one just like we did before, this could be written as 3 divided by 2 all to the power 2, then all to the power x minus what we have here, 3 divided by 2 all to the power x is equal to 1. Now let's remember this power rule. If we have a to the power n or to the power m, this could be written as a to the power m or to the power n. So you can interchange their positions. So let's go ahead and then use this idea on this part. So we're going to have 3 divided by 2 all to the power x, then all to the power 2 minus 3 divided by 2 all to the power x is equal to 1. Then from here we will let m equal to 3 divided by 2 all to the power x. So the equation now becomes, let me change the marker, m to the second power minus m is equal to 1. This is quadratic equation, and to solve any quadratic equation we need to equate everything to 0. Now let's go ahead and then use the quadratic formula since factoring method can solve this one. So with the quadratic formula, we have m in this case will be equal to minus b plus or minus square root of b squared minus 4ac, all divided by 2a. b is the coefficient of m, which is -1, so we're going to have m is equal to minus 1 plus or minus square root of minus 1 squared minus 4 times a, which is the coefficient of m squared, which is 1, then times c, which is the constant over here, that is -1, all divided by 2 times a, where a is 1. So we're going to have m is equal to 1 plus or minus square root of -1 squared is +1. -4 times 1 times -1, that is +4, plus this one making 5. So we're going to have 5 divided by 2. So this implies that it is either m is equal to 1 plus square root of 5 divided by 2, or m is equal to 1 minus square root of 5 divided by 2. Remember that initially we let m equal to 3 divided by 2 all to the power x. So when m is equal to the whole of this one, we're going to have 3 divided by 2 all to the power x is equal to 1 plus square root of 5 divided by 2. Or when m is equal to this one, we're going to have 3 divided by 2 all to the power x is equal to 1 minus square root of 5 divided by 2. Now let's consider this equation first. 3 divided by 2 all to the power x on the left hand side of the equation is always positive. No matter what the value of x is, this whole thing will be positive. Now on the right hand side, we see that because of this root 5, it will make everything negative. So for real answers, this statement is not true. So let's go ahead and then consider this equation over here. From here, let's go ahead and then take log in base 3 divided by 2 on each side of the equation. So we're going to have log in base 3 over 2 of 3 divided by 2 all to the power x is equal to log in base 3 over 2 of 1 plus square root of 5 divided by 2. From the properties of log, the power now becomes the leading number over here. So we're going to have x log base 3 over 2 of 3 over 2 is equal to log base 3 over 2 of 1 plus square root of 5 divided by 2. Now we know that log base a of a is equal to 1. Therefore, the whole of this will be equal to 1. So we're going to have x times 1, which is x, is equal to log base 3 over 2 of 1 plus square root of 5 divided by 2. And we can simplify this further. We can write this as x is equal to log base 1 plus square root of 5 divided by 2, or divided by log base 10 of 3 divided by 2. That is change of base, right? We have changed all the bases to base 10. And we can simplify this further as x is equal to log base 10 of 1 plus square root of 5 minus log 2, then all divided by log 3 minus log 2. 1 plus root 5 is simply 3.236, then minus log 2 divided by log 3 minus log 2. Log 3.236 is simply 0.510, then minus log 2 is 0.301, all divided by log 3 is also 0.477 minus log 2, which is exactly the same as this, 0.301. Now let's simplify this further. We have x is equal to 0.510 minus 0.301, that is 0.209 divided by 0.477 minus 0.301, that will also be 0.176. Now if you simplify this further, we have x approximately equal to 1.1875. So approximated value of x is this one. Now let's go ahead and then test whether this value of x is correct. From the question, we are given 9 to the power, let me change our marker, 9 to the power x minus 6 to the power x is equal to 4 to the power x. So we're going to have 9 to the power 1.1875 minus 6 to the power 1.1875 is equal to 4 to the power 1.1875. Now, 9 to the power, the whole of this will give us 13.588, then minus 6 to the power, the whole of this one here will also give us 8.396. Then on the right hand side, 4 to the power, the whole of this will also give us 5.187. Now, if we take the whole of this from this one, we're going to have 5.192, and on the right hand side we have 5.187. You can see they are not the same, but as soon as we run all of them to the two decimal places, we're going to have 5.19, which is the same as 5.19. So basically, they are the same when we run them to two decimal places. But here it changes a little bit. But in two decimal places, we have the same thing. So it means that the value of x is approximately equal to this one, which is correct.